Okay, we're looking at section 2.2, logic. And we're going to look at statements. It's not going to feel like geometry or a math class as such, but we're working on making arguments. It's kind of the whole essence of this. And so we need to make a logical argument. All right. Penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows. And then it says logic, another thing that penguins aren't very good at. Cute little penguin cartoon, and this will make more sense after we go through today's lesson. Why does this or does this not make sense? Okay, this we will go through in class, but I want this in your notes. So T stands for true. True, if something, like a statement, we have two statements. If something is true and true, then the overall statement is going to be true. If it's true and false, overall the statement will be false. False and true, overall statement false. False and false is equal to false. I'm going to do an activity, hopefully that will help us know this without having to look at this list, but I still want you to have it in your notes. If it's true or true, the whole thing's going to be true. If it's true or false, you only have to meet one of the conditions for the overall statement to be true. Same here. This is basically the same statement. False or true, well, only one statement is true, so the overall statement is true. False or false is going to be false. You need to recognize when you see this symbol right here, that's the negation symbol. Basically, every time you see it, you're going to say not. Okay? So you would say not P or not Q. Okay? Once again, so bizarre, isn't it? This is a symbol for the or. So I could have written all of these statements with the symbols instead, but we're going to leave that there. And then and, I want to point out and, oh, look at that symbol right there. And the A, capital A, has that same kind of a connection as that symbol. All right, lovely. Press pause if you don't have that written down. That needs to be in your notes, meaning hopefully will come a little bit more in class. Okay, example 1. Use the following statements to write a compound statement for the conjunction of P and Q. I'm not worried about this word conjunction. I want you to look at this right here, P and Q. Then find its truth value. All right? 1 foot is 14 inches. That's my P statement. And then I also have a Q statement. Okay, notice this seems so basic to me. You're going to look at P statement and the Q statement. The P statement, 1 foot is 14 inches. Aren't you like, Mrs. Talley, that's wrong. I'm going to get extra credit. No, no, no. This is not a mistake. 1 foot is 14 inches is false. Then I have the word and I look at this. September has 30 days. And we're in the month of September right now, and it does have 30 days. So I'm going to put down true for this. So is something false and true? It can't be both false and true. So the overall statement is false. So that's what I mean by truth value. The truth value is false. All right, and then I have this, oh, you're going to love this. Oh, the answer. This is like the book answer. 1 foot is 14 inches, and September has 30 days. So that's like your statement. P and Q is false because P is false and Q is true. All right. All right, example number 2. Use the following statement to write a compound statement for the conjunction not P and R. So basically, this translates to not P and R. So P, as we've already said right now, is false. R, a plane is defined by 3 non-collinear points. That's true. If P is false, but then I say not P, then I'm going to put down a true. Because I'm negating. I'm doing the opposite. That's what it means to when you say not. You're doing the opposite. So P is normally false, but I'm doing the opposite, so I have true. Then I put down the word and R is also true. So if I have true and true, what's the overall? This is where you look back to that first thing in your notes, those little charts. T and T, the overall statement is going to be true. The truth value is true. All right, once again, let me wow you because you are just astounded by this Promethean board activity, little thingamajinger. A foot is not 14 inches. Notice how they negate it. and a plane is defined by 3 non-collinear points. Not P and R is true because this part is true and this part is true. So basically I just said the true and the overall statement is true. Example number 3, using the following statements to write a compound statement for each conjunction. Then find its truth value. All right, P and R. So I'm looking at the statement P and the statement R. Notice what they're doing. They're putting an extra statement in there so you can pick out the right ones. June is the 6th month of the year. If you need to count, yeah, January, February, March, April, May, June. So this is true. And a turtle is a bird. That's so funny because that is so not true. So I've got a true and a false. So P is true and is my statement in between, and then R is false. So overall, this would have a truth value of being false. Okay, and if you were to write this out, you would say June is the 6th month of the year and a turtle is a bird. Oh, wow. And here's the statement. June is the 6th month of the year and, notice how they have that word there, and a turtle is a bird. Overall, that statement is false, just like we said here. Okay, example 4. Isn't this weird, all this like words that we're using in our geometry? We're going to write a statement, P or Q, and then find its truth value. So I've got to look at the P, I've got to look at the Q. AB is a proper notation for line AB. That is false, right? Oh, you're thinking, oh yeah, that's the same thing. Wouldn't it be correct if it was line AB? Oh yeah, this is segment AB. All right, centimeters are metric units. That is true. Centimeters are something in metric. So when I have P or Q, my P value is false, and then I have or true. Oh, look back at your chart if you have to. Hopefully we'll clarify this so eventually you'll be able to just look at this and say, fort? No, we're not going to say fort. We're going to say false or true. Overall, because of that or, you only have to meet one of the conditions, and if one of the conditions is true, then the overall statement is true. All right, let's see. Oh, yay. Segment AB is proper notation for line AB, or centimeters or metric units. P or Q is true, because Q is true. It does not matter that P is false. Bizarre, isn't it? All right, example 5. We are now going to use this statement, Q, and remember what this stands for? This stands for or R. So I'm looking at Q and R. Centimeters or metric units, true. R, 9 is a prime number. 9 is not prime because 3 goes into it. It would be prime if it was only divisible by 1 in itself. But since it's divisible by 3, that makes it a false statement. So my Q statement is true, then I have or, and then R is false. Oh, true or false? The overall value of this will then be, the truth value will be true. All right, let's see. Whoa. Yeah, I should have a little music with that, shouldn't I? Centimeters are metric units, or 9 is a prime number. What they've done is just rewritten that out with the word or in between. Q or R is true. Because Q is true, it does not matter that R is false. Okay, kind of like the same thing as we had on the previous question. Example 6, use the following statements to write a compound statement for each disjunction, then find the truth value. Okay, so now I'm looking at P or R. The P value, 6 is an even number, true. I'm going to look at R. R, a triangle has 3 sides, true. So basically I'm saying true or true. Look at your chart. Probably don't even need to look at your chart. You probably know overall truth value is going to be true. Whoa. 6 is an even number, or a triangle has 3 sides. True. Example 7. Each of the following statements, use each one of these, find the truth value. Okay? This is a not Q or not R. So let's go look at Q and R. Q, a cow has 12 legs. No, we don't all live on a farm, but I think we're all pretty confident that it's going to be false. And if I look at R, a triangle has 3 sides, is true. Okay? So normally this would be false or true, but I'm negating it. So the negation would be the opposite. So I'm going to say this Q statement now turns to true, or I would write a cow does not have 12 legs, and to negate R, I would say a triangle does not have 3 sides. So the truth of this then becomes false, because I would put the word, the not in that statement. So now I would say not Q would be true, or, and then I would say not R, which the true then goes to a false. So now I have a true or a false. The overall statement will then become true. Whoa! A cow does not have 12 legs, or a triangle does not have 3 sides. The overall statement is true. Just like we said. All right, this ends this lesson. Yeah, little odd, but we will keep working on that a little bit in class to hopefully clarify any questions you have, but that should at least get you started.